Welcome back to the workshop. We want to continue talking about coloring a graph. The chromatic number of a graph is the smallest number of colors that it can be colored with. So if a graph can be colored with n colors, but no fewer, then it's said to have chromatic number n. And that's what we want to determine here. We want to find the chromatic number of these graphs. So to find the chromatic number, we usually find it by coloring a graph in a very careful way, let's say. The graphs that we will consider are relatively simple. Of course, these things can get very complicated. So we'll take a look at some simple examples and go from there. All right, so let's start by coloring some random vertex. Let's call this one blue. Now, the adjacent vertices cannot be the same color, so let's color the adjacent vertices something different. Let's call this one yellow. And since this adjacent vertex is not adjacent to this one, then we can also color this one yellow. Excellent. Next, we can color the adjacent vertices to these two. This one could be colored with blue again. And of course, if I don't need to, I'm not going to use a new color because I'm trying to find the minimum number of colors. So adjacent to both of these is this guy here, so we can use blue here as well. And adjacent to both of those is this guy, and we can use yellow here. Again, none of the yellow vertices are adjacent to one another, and none of the blue vertices are adjacent to one another. So we're doing good so far. We can continue to color. Let's see here. Adjacent to a blue, we need something not blue. That'll work. Adjacent to blue, we need something not blue. Good so far. And adjacent to yellow, we want something that's not yellow. So we were able to color this graph with just blue and yellow. So it has chromatic number 2. Again, chromatic number 2 because we were able to color it with 2 colors. For our next example, we'll start it the same way. We want to pick an arbitrary vertex and color it with some color. So let's go with blue. Well, let's color all of the adjacent vertices yellow, as long as it's appropriate to do so. So this one can be yellow, and this one is not adjacent to that, so it can be yellow. And this one is adjacent. This one is adjacent to that, so we color this one yellow. But once we get to here, this vertex is adjacent to both of those and to this one. So we actually need another color. Let's see if I can find a different color to use here. All right, now the question is this pink or is this red? We'll call it red, but we need a third color. And we can continue coloring now. Now this vertex here could be blue or it could be yellow because it's not adjacent to any right now, but we should be careful. If we chose this to be blue, then I suppose we could use red right here. So let's actually do that. Let's use blue. And then we can continue and use red right here. Now, is it necessary that we did that? No. We could have actually labeled this a little bit differently. So we want to be very careful when we are labeling as to not create any situations where we're forced to introduce new colors. So if I wanted to keep it at a minimum, forgetting that I had used red, I may have also labeled these as blue and yellow. So there are always options as to how we label our vertices. But in this case, because of our triangle, we had to have 3 colors. We'll actually find that whenever all of these cycles are of even length, as in this example, then we'll be able to color it with just 2 numbers. And if there exists a cycle that is odd length, then we'll have to use more than 2. We don't have a lot of theorems that give us much stronger statements, but that's pretty good on its own. We'll talk about that more a little bit later. But to finish this example, we found that this has chromatic number 3. Again, it has chromatic number 3 because we were able to color it with 3 colors and no fewer. All right. Again, there will be a little bit more to this section, so I look forward to seeing you guys again soon.